Imagine that you're building an app for a bookstore that lists books for sale. You have a model book object, book type that is properties for names and publication year. And so on page 296, they have that option there, and I can bring it up on the screen as well here. I can get to the chapter quickly here. Again, we're going to jump to navigation and workflow. So in this chapter, it's probably going to take us pretty much to the end of the semester, pretty much going through a lot of this. Let's just look. Optionals, again, is this chapter is mostly about storing data and pulling data from a stored object of some kind. Typecasting and inspection, guarded. These are all very short. Consonant and variable scope, enums, segues and navigation controller, tab bar controller, view controller, and building a simple workflow. So all of these are kind of not very long, but important to know. And then we're going to jump a little. Oh, I just jumped there, didn't I? I didn't want to jump there. In addition, we're also going to jump a little bit down here to working with the web, so that when we connect our National Park app to a website, you're going to have to jump here. We're going to go over this a little bit here, working with HTTP and a URL. So we'll jump around a little bit. It's very simple, though. Connecting to a website is very easy. It's not that difficult. Same with the map. We'll go over the map. They don't really have a map in there, but I have a video that explains the map quite easily, so we'll jump there. And then the last part as far as jumping is that we will be using the table layout. So we will be jumping here, table views, and so on. And then, some of the things that you can do with a table layout. So we will jump around a little bit, but those are kind of the things. The table layout, working with the web. Oh, it jumped again. And then right here, and then again, pretty much this whole chapter. So let's get started with, again, we're talking optionals. One of the greatest strengths of Swift is its ability to read code and quickly understand data. When a function may or may not return data, Swift forces you to deal properly with both conditions. Swift uses unique syntax called optionals to represent when a value may or may not contain a data. In this lesson, you'll learn to use optionals to properly handle situations when data may or may not exist. Again, these are the kind of terms that they're going to use, forcing you to unwrap things. How to name things properly, I think, is important. Optionals are useful in a situation when value may or may not be present. An optional represents two possibilities. Either is value and you can use it, or there isn't value at all. Imagine you're building an app at a bookstore. We already talked about, you have a model object book. There's your struct right there, book. And it has some properties, name and publication year. Well, maybe you don't know the publication year. That's what they're talking about here. So far, so good. So again, you got a struct. You got the name, which is a string, of course, which would be the name of the book. And then, of course, the publication year would be a date, which would be an integer. So it's int. And so then, of course, you start with the name of the book here. First Harry Potter book, second Harry Potter book, third Harry Potter book. Then you got the book, which is the struct here, book. And then, of course, you got a name, and then, of course, the string, and a publication year, which is an integer there. So far, so good. You understand that, I hope. And then, of course, you can make books, which is a consonant that has all three here. So far, so good. Now imagine you're building a screen that shows a list of books that have been announced but haven't yet been published. How might you initialize the books without a published date? What do you assign to publication year? Of course, down here, their example, they put 0 for the publication year, but of course, that would be 2,000 years old. So again, the currently year isn't accurate either because it may be released the next year. There's no known launch date. Nil, N-I-L, represents the absence of value or nothing because there is no publication year yet. Publication year should be nil. And so they actually put that in there, right there, as a nil. That way it doesn't crash, because if you don't give publication year a value in this line, it would stop right there. It would give you an error. So this has to have a value of some kind. Yes?
If you put an exclamation point there instead of no, what would have happened? Does the exclamation point do? It allows there
Yes.
to run without there being.
Yes, it would fix the error. Yes.
Okay.
That's why we have, yeah, they'll talk about that as well. That looks better, but the compiler throws an error. All instance properties must be sent during initialization, and you can't pass nil to the publication year parameter because it expects an integer. So it doesn't know what nil is. That's the problem with this example. It's expecting a number here, so that would give it an error. Options solve this problem by providing a wrapper around a value that may exist. You can think of an optional as a box that when opened will contain either an instance of the expected type or nothing at all, nil. Every type has a matching optional type which you declare by adding, this is the question mark, after the original name. In this case, you need to update the type annotation on publication year property to this with an, so you put the question mark over here. Where is it? Here, right there is where you put the question mark. Okay, so if you put it there, then in this case you need to update the type annotation on publication year property to int with a question mark and int optional. See, it's right here. Yeah, then you can put nil here is what they're talking about, is what I'm assuming. Note that you can't create an option without specifying the type. Consider what happened if you tried to let Swift infer the type. In this example, type inference will assume your variable is non-optional. So in this case, is this a so there's a variable server response. We all know what a 404 error is. It's a bad website, right? But is it a it doesn't know what it is at this point, is what it's saying. In this example, type inference will assume your variable is non-optional. In this example, type inference doesn't have any information to determine the data type if the data is nil. So it doesn't know, is this a word or is it a number? For these reasons, the safe method is to specify the type when creating the optional. Take a look at the following correct approaches to integer with a question. Variable server response, and then of course they put the question mark there, equals 404. Set to 404, but could be a nil later. Variable server response, this could set to nil, but could be an integer later. So by using the question mark, it's just putting a value there, but it can be updated or altered later. Is that? I guess that's what they're assuming, right? It could be an integer or it could be something else. How do you determine whether or not an optional contains a value? How do you access that value? You could begin by comparing the optional to nil using an if statement. If the value is not nil, you can unwrap the value using force unwrap operator or the explanation, or yeah. So again, if publication year is, and then the exclamation point equals nil, let actual year be publication year print value. So again, this is assuming that this could be a number or integer. If you skip the comparison of the optional to nil and you force unwrap an optional that doesn't contain a value, the code will generate an error and crash when you try to run it. So again, if there is nothing in there, then it will crash, is what they're trying to say. So let unwrap year equal publication year print unwrap number. So again, this is making a consonant called unwrap year equal to the publication year with the oh jeez, let's see. I hope I highlighted that with the exclamation point and then print. Okay, so if you skip the comparison of the optional to nil and you force unwrap an optional that doesn't contain a value, the code would generate an error. It seems like a good practice to compare an optional to nil before attempting to use the contained value, but it also feels somewhat risky. As you recall, safety is one of the primary design goals of Swift, and a safe language should alleviate programming errors before the code is executed. With optional binding, Swift unwraps the optional, and if it contains a value, assigns the value to a consonant that's safe to work with. This approach eliminates the need to continue working with nil. The syntax for the optional binding looks like this. If let consonant name equals some optional, consonant name has been safely unwrapped for use within the braces. So again, they're using the value inside here. And hopefully it doesn't crash. If some optional has a value, the value is assigned to consonant name and is available only within the braces. Take a look at how optional binding works on the previous book example. If let unwrap publication year equals book.publication year, print the book was published in, and then of course this is unwrapped. Again, they're saying to use it within the braces right there. Just like other if statements, you can add an else clause. That would be if the publication year is something different, right? You could put this in its place. So if this doesn't have a value. Swift comes with many functions that return optional values. Consider the example where you have a string whose value is set to 1, 2, 3. You can see that that string could be converted into an integer. Let string 1, 2, 3. Let possible number be an integer. What if the string can't be converted? Let string be Cynthia. Let possible number be integer. Swift infers possible number to be an integer with a question mark, of course. Type because the integer string initializer may or may not be able to successfully convert the string into an integer. If the string can be converted into an integer, possible numbers will hold that value. If it can't, possible number will be nil. If you want to write a function that accepts an optional as an argument, simply update the type in the parameters list. Consider the print function that accepts a first name, middle name, and last name, but allows the middle name to be nil since not everyone uses a middle name. So again, they have a question mark there. So again, they're printing a full name, so you could have a first name be a string, middle name could be a string, or it's nothing, right? 0. And then this one could be a string. So by putting the question mark there, we can kind of blow it off, I guess, without having value. The same is true for a function that returns an optional. Just update the return type. For example, a website URL returns the text from the page. The return text is optional because the URL may not work or may not return any text. Again, to keep it from crashing, they put a question mark on this string. Any initializer that may return nil is called a failable initializer. Early in this lesson, you saw how the integer initializer attempts to create an integer from a string and return nil if it was unable to convert to a string. For greater control and safety, you may want to create your own failable initializer and define a logic for return an instance or nil. Consider the following definition for a toddler. So we have a toddler, and of course we have a name, which is going to be the name, and how old, which would be an integer. An example, every toddler must be given a name as well as an age in months. However, you may not want to create an instance of the toddler if the child is younger than 12 months or older than 36 months. To provide this flexibility, you can use the init with the question mark to define a failable initializer. The question mark tells Swift that this initializer may return nil and that it should return an instance of a type toddler. Of course, with the question mark there. Within the body of initializer, you can check if the given name is less than 12 or greater than 36. If this one is true, Swift will return nil instead of assigning a value to the age. So again, they're going to have an if statement there, and they have the question mark there. So the name is a string, months old is a integer. If the month is less than 12 or older than 36, return nil, else assign the value here. So that's what this code is trying to say. When you use a failable initializer to create toddler instance, an optional will always be returned. To safely unwrap the value before proceeding to use it, you can use optional binding. Let possible toddler equal toddler, name Joanna, months 14. If the let toddler possible. Print toddler birth name is toddler birth name. It's old, else age or specified for toddler is not between 3 years of age. So they gave you an example. It's also possible for an optional value to have an optional properties, which you might think of as a box within a box. These are called nested optionals. In the following example, note that every person has an age and may have residence. A residence may have an address, but not every address has an apartment number. So again, we're making a person, which is an integer, is their age, but they have a residency with a question mark. So again, putting the question mark there makes it flexible. That's a term you want to describe it. It's flexible. So the residency right here could have an address. Again, the address could be flexible. So I guess if you need to have a flexible value, you just put the question mark in there, I guess is what the whole point is. Class address, variable building numbers equals a string. Yes, address would be, or street name would be a string, but the apartment number, some people don't have apartment numbers, put a question mark there. That's the whole point of this all. Unwrapping nested optionals can require a lot of code. In the following example, you check an individual address to find if he or she lives in an apartment. To do this for a given person object, you must unwrap the residence option, the address option, and the apartment number option. Using if-let syntax, you have to do quite a bit of conditional unwrapping. If-let the residence equals person residence, so they're testing to see. So they're making a constant, because it's a let, called the residence, and of course there's person, resident. If let the address equals the residence on address, if let the apartment number equals the apartment number there, print she lives in an apartment number, and then put their number in there. So they're, even if we're using the question mark and a nil, you might need to do some evaluation to see if it's being used or not. I think that's what the point here is. And then, but there's a better way to do this. Rather than assigning a name to every optional, each property can be conditionally unwrapped using a method called optional chaining. If the person has a residence, the address has an apartment number, and if that apartment number can be converted to an integer, you can refer to the number using the apartment number as seen below. So again, there's a better way. They're saying, so again, the apartment number. When changing together optionals, a question mark appears before each optional in the chain. If a nil value breaks the chain at any point, the if-let statement fails. As a result, no value is assigned to the consonant. If the code inside the braces will never execute, in this example, person has a resident with an address that includes an apartment number, so the print statement will execute. Okay. Implicitly unwrapped optionals. An object cannot be initialized until all of its non-optional properties are given a value. But in some cases, particularly with iOS development, some properties are nil for just a moment until the value can be specified after initialization. For example, you're using Interface Builder to create outlets so that you can access a particular piece of interface in code. And of course, there's the view controller, right? So we make a class for a view controller, IU view controller. And then, of course, the label, let's say you have a label on there and it doesn't have text in it yet. They're using the exclamation point there. If you were to develop this class, you know that anytime a view controller is created and presented to the user, there will always be a label on the screen because you added it in the storyboard. But in iOS development, the storyboard elements aren't connected to corresponding outlets until after initialization takes place. Therefore, a label must be allowed to be nil for a brief period. What about using a regular optional UI label with a question for the type? The standard option will require an if-let syntax to completely unwrap the value, providing a safety mechanism for data that may not exist. But you know the label will have a value after the storyboard connects to the outlet, so unwrapping an optional that isn't really optional feels cumbersome. To get around this issue, Swift provides syntax for an implicit unwrapped optional using the exclamation mark instead of the question mark. As the name suggests, this type of optional unwraps automatically whenever it's used in code. This allows you, so you don't have to test it with the exclamation mark is what they're trying to say. Right? With the question mark, you do. This allows the use label as though it were an optional while allowing the view controller to be initialized without it. Implicitly unwrapped optional should be used in one special case when you need to initialize an object without supplying the value. But you should know you'll be given the object a value very soon afterwards. It might seem convenient to reach for the implicitly unwrapping optional to save yourself from using if-let syntax, but doing so you'll remove one of the most important safety features from the language. Okay, so let's do the quiz and then we'll do this playground right here. And so we're gonna do this lab right here. We'll do it together. I have the code for you already. So here, I'll print it out for you. Here it is, it's right here. So I'll try and provide the code. Here it is. It was hard for me, that's why I had to print it out, okay? And I know it's hard for you, so let me print this for you. And how many people are here? 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know if I have enough paper. Let me see if I have paper. Yeah, I don't know. Let me see if I have. There's some paper here. Let's see. How about if I print one and I'll go use the copier? How about that? Might be easier. So let me print one. So you can download and open the file and get started. Do you know where the file is located? If you don't have it. So the file is here. Boom. If you don't have the file to do this lab right here, you go to the first lesson, right? Go to the first lesson and download files in class book right here. If you don't have the file to do this with me, and it's this one right here, right? If you don't have them already, right? You should have these probably on your computer by now. And it's under Chapter 3, Optionals. And we'll do it together. So let me go make a, so let me pause the file. Let me close this window here. And not this one. This one. There. There. Student resources. Number 3. Number 1. Lab. This one. Open it. I know it says download it off the internet. It's okay. So after I started going through this, it made a little bit more sense to me. So again, let's start at the beginning. Throughout the exercise in this playground, you will be print optional values. The Swift compiler will display a warning. You will get this warning throughout. Usually not. I don't think on this first page, but on the second and third page, you'll get this message. It says just ignore it for now. Imagine you have an app that asks the user to enter his or her age using the keyboard. When your app allows a user to input text, what is captured for you is given a string. However, you want to store this information in an integer. Is it possible for the user to make a mistake and for the input to not match the type you want to store? Declare a consonant. So again, what if they put in an E when it should be a integer right here? See that? So, 34 in an E. To simulate a typo while typing age, then declare a constant user age of type integer and use the initial integer initializer and pass it to user input age. What errors do you get? So again, we can just go down here and type. You can see the example that is written there. So first they want you to set a user input age, and so we're going to make a constant, let user input age, and then of course 34. So far so good. Did I give you one?
No.
There.
Thank you.
Let's user's age be integer with a question mark. So here we go. Let user age be an integer with a question mark equal to integer, and then of course user's input age and then of course let's put an E in there. It still comes out nil here. Declare a constant user input age and of a type string and assign it to 34E to simulate a typo when typing age. Then declare a constant user age type integer and use the initializer and pass the user age. What error do you get? It didn't give me an error, did it? Oh, because I put the question mark in there, huh? What if we take it out? Well, down here, then you get an error. So again, put the question mark in and take it out. Go back and change the type of user to int with a question mark and print the value. So again, it was put in the question mark. And it seemed to work fine. So I guess that's the whole point of the question mark. Does it work without the E in there? Did you mean that or that? Then they want you to print. Let's try it. Let's put the E back in there. And then let's print. Print user age. Did I spell it wrong? Oh, I did. There we go. So they're saying it comes a nil because it doesn't know this should be an integer, right? That's what they're saying there. So let's get rid of the E and see if it works now. Then it gives you an optional of 34. You see that? So again, if they type in the wrong E there, it's going to give you a nil because the E is conflicting with the user's input age. Put 34 in there and it gives you 34. I guess now go back and fix the typo of the value user input. Is there anything about the value printed that seems off? Print user's age again, but this time unwrap user's age using a bang operator. And of course the bang, I guess, is the explanation point. So put a what explanation point there. Still gives me 34. but it gives me a 34. Now use optional binding to unwrap user's age. If the user's age has a value, print it to the console. So I'm going down here. Oh, I started putting everything up here. I'm jumping here. So now go back and fix the typo on the value user. If there's anything about the value printed that seems off, we already did that. I put the exclamation point in there, didn't I? Now use an optional binding to unwrap user's age. If user's age has a value, print it to the console. So again, they want you to test it. Is it a value? Then you can use it instead of a nil, right? So if let user age equals user age, and then of course print user age. Did I spell it right? Yeah. Okay, so up here, let's put our E back in there to give us an error. Let's comment this out. Again, we get the error here. Let's get rid of the exclamation point. It gives us a nil. And down here, it's not going to print because there's an error. But if I go up here and I get rid of the E right there, this should then work down here. So by using the if right here, if the user's age is a legitimate number, do something with it. If it's not, don't do anything at all. Again, let's put the E back in there. Okay, so this is going to give you nothing. Down here, nothing. But if we put it in, it will give us something. So far, so good. You understand why the if statement works? It's basically a way of testing your value to see if it's correct. Okay, and then up here, they're just talking about how to initialize it. Go back and change the type of user's age to int with the question mark and print the value. We already did that. Why is the user's age value nil? Provide the answer in the comment. User's age is nil because 34e cannot be properly converted into an integer because the character e. We went back and fixed the typo. Prints the user's age again. Oh, well, let's get rid of the typo. Oh, it is out. Okay. And of course, it gives us 34. But this time, unwrap user's age using the bang operator, and that's what they had with the exclamation point. Okay, so that gives you the value. So putting the exclamation point in there, you can pull the value out of whatever it is. But again, if it's only correct, right? If you put the E back in there, that's going to give you an error message here, right? Because this is not going to work. So if I put the E back in there and I come down here, it gives you an error because this is not a legitimate value. It's giving you an error. So by putting the exclamation point in there, you can pull the data out if it's proper. Okay? Then down here, they're using another way to test by using the if statement. If user's age equals user's age, then print user's age. Again, you're getting 34 here again. This time, and let me get rid of this for just a moment. Let me comment that out. If we go and put in, so we don't get the error, if we put in the error here, and then come down here with the if statement, it's going to give you a nil. It should give us a nil, no? Didn't it give us a nil last time? Oh, it doesn't do anything, right? It doesn't do anything. This if statement won't run. There's a value there, but it's incorrect. So if we take the E out, it then gives you a value. Okay, let's go to next exercise. Okay. This one's a little even harder. This exercise reinforces Swift's concepts in the context of a fitness tracking app. Many APIs that give you information gathered by the hardware returned optionals. For example, in an API for working with a heart rate monitor may give you a nil if the heart rate monitor is adjusted poorly and cannot properly read the user's heart rate. Declare a variable heart rate of type, of course, integer with a question mark, and set it to nil. Print the value. So again, this example, we have a variable heart rate. Heart rate. I think that's right. Heart rate. And we're going to make it an integer with a question mark. And equal that to nil. Then, well, print it. Oops, print heart rate. And of course, they said you're going to get this error message anyways, right? At the beginning of the chapter here. Declare a variable heart rate of type integer and set it to nil. Print a value. In this example, if the user fixes the position of the heart rate monitor, the app may get a proper heart rate reading. Below, update the value of the heart rate to 74. Print a value. So again, it could be... let's try heart rate. And then, well, it says 74 right there. You don't even need to print it, but we can print it. And you get an optional 74. As you've done in other app exercises, you created a variable HR average type integer and use the value stored below and the value of the heart rate to calculate an average heart rate. So they have a bunch of consonants, as you can see there. One is 80, 76, 79, and 70, it looks like. So then they were going to compare them together. So here we go. Let old heart rate, HR, yeah, I know. And what were the values here? 76, 79, 70. I wish mine was that low. What's that?
You have 2 times. There's the same session in the previous
What's that?
Line 26.
Oh, it's up here. Doing it twice. There we go. If let heart rate equal heart rate, then what? Let HR average equal, and then let's do the mathematical equation. Let's just copy and paste. I'm going to copy and paste. Save on time. Oh. And then, of course, since there's 5 of them, you got to divide. So we can print HR average else. Oh, you got to put your bracket in there. Else. And let's copy this all. I don't feel like typing it all. Oh, didn't want to do that. Can't copy that. As you've done it, oh yeah, we already read that. If you didn't unwrap the value of heart rate, you probably noticed that you cannot perform mathematical operations in an optional value. You will first need to unwrap heart rate. So again, in order to, you kind of need to make it a number to be able to do that. If it's just a basic string of letters, it doesn't know how to add them all together, right? I guess that's what they're kind of explaining. So if you didn't unwrap the value of heart rate, you've probably noticed that you cannot perform mathematical operations to an optional value. You will first need to unwrap heart rate. Safely unwrap the value of heart rate using optional binding. If it has a value, calculate the average heart rate using the value and the older heart rate stored above. If it doesn't have a value, calculate the average heart rate using only the older heart rates. In each case, print the value of average heart. I wish mine was that good. So what do you think? Do I need to add anything to it? What if we didn't have a value here? Could we do that? If we didn't have a value in here. What if we, like before, put an E in there? Then you got an error. What would come out down here? Nothing. I like breaking it. Let's read it from the beginning again. Many APIs that give you information gathered by hardware return optionals. For example, an API for working with heart rate monitors may give you a nil if the heart rate monitor is adjusted poorly and cannot properly read the user's heart rate. Declare a variable heart rate of an, oh, that's right, heart rate with a question mark here. Okay. What if we got rid of the question mark? What would happen? Heart rate down here is what? Initializer for conditional binding must have optional type, not integer. So they're talking about if we didn't have the question mark up here, right? So the whole point of this all is that in order to make this work as far as heart rate, it needs to be an optional from the beginning. Does that make sense? Where's yeah, first it tells heart rate to be something, then we told it to be 74, right? It has nothing in it right there. But it's an optional, and then they go and give it a value which is an integer, and then I can go and add that integer because this is a number right here, right? That adds them all together, divides by 5, gives you an average. But again, if this was not an integer, where we put the E in there, it's going to give us an error. I don't know.
Is that essentially saying that if the heart rate is equaling, if the arm band's not all the way, the heart rate would give you something that would equal an integer, possibly, and that way you get nil rather than.
That makes it an optional. That's all. Okay, let's move on to page 3. Hopefully that. Let's try page 3. Well, there's my 34 with the E again. Love that 34 with an E. If an app asks for a user's age, it may be because the app requires a user to be over a certain age to use some of the services it provides. Write a function called checkAge that takes one parameter of a string. The function should try to convert that parameter to an integer value and then check if the user is over 18 years old. If he or she is old enough, print welcome. Otherwise, print sorry, you are not old enough. That's like it's like a Disneyland if you're not tall enough, right, to get into the rides. I always used to try and stand on my tippy toes so I was tall enough, right? Okay. If the string parameter cannot be converted to an integer value, print sorry, something went wrong. Can you please re-enter your age? Call the function and pass it to user's input age below as the single parameter, then call the function and pass in a string that can be converted to an integer. So again, they start with let user input age equal a string as 34E. We always love that 34E. So again, we're going to check it. So they make a function called checkAge with a property of age, which is a string. Then they convert it into an integer optional with the question mark, right? Then they do an if statement to compare it. If the let age is an integer age, if it's greater than or equal to 18, say welcome. Else, sorry, you're not old enough, return age. Else, sorry, something went wrong. Can you please re-enter your age? Okay, so again, all they're doing is testing the user input. What is their input? So let's say this is a box, right?
I was just going to say, so is using a question mark essentially on the integer mainly for if you're going to be putting in data in there that they could accidentally put in something that's not an integer, so therefore they'll give you a message of nil, and then you can correct them to put in the right information?
Yeah, so the whole point here is that let's say you have a box on your app, right? And the person clicks on the box and they put in some information that is not correct. Just almost like on your website, right? Where we can do the, when we're making a form on our website and we can test that form to see if they put the right zip code in, did they put the right thing in there, and if they put an E in there, like this is going to give us the error. So if we look at the code there on page 3 there in this, what we're writing here, most likely it's going to say, sorry, something went wrong. Can you please enter your age? So let's try it. So let's put a function, check age, and then of course we're testing somebody's age. So let's make a property age, let's make it a string, and then we're going to convert it or unwrap it or get a return as an optional. Integer optional. Then we're going to test it. If let, so the whole if let is a testing age is equal to integer age. And if this is the test to see if it's over 18. And so if it's a number, and that number is over or greater than or equal to 18, then put print welcome to the army. All right, they're 18, they can join the army. Else, print, sorry, but you need to be older to join the army. Then you got to return the value, age. Another else. And of course we're going to return nil. Oops, lowercase n. Do I have enough brackets? Doesn't know what age is. You need one here. Need one here. This one wrong here. There we go. I have too many now. So nothing happens. So what if we put in 34? Would it do what? No, I just got 34 there. I was hoping to get that. So we make it a function check. Oh, did we print though? We didn't print the age. So we got to put a print down here. Check age. Whoosh. Check age. A-G-E. Age. User input. Age. Is a nil right now because it's an E, right? Print, check, age, and they're going to put 17 in there. So it says, sorry, you need to be older. What if we put 20 in there? What do you think we'll say? Welcome to the Army. Okay, so let's read what it's doing. So the first line says, let's make a consonant called user input age, make it a string. Then they're going to convert that string into an integer. That's an optional with the question mark, right? So convert it to an integer with a question mark. Then they test it. And so down here we put there, what if we put an E in there for the 20 with an E? What do you think it's going to print out down here? Something went wrong. And so what if we put 18 in there, which should be, ooh, 218. Welcome to the Army. Okay. So let's look at the code again. Let's look at first line. It's making user input. So let's assume this is a box on your app, right? I think that's the whole point of this all is that we're talking, I mean, I think the last one, you have a box, the user puts some data in there, we're testing to see that data, and whatever data they put in there, is it correct? So you got user input, which is a consonant. We convert it to a string with that. Then you make a function called check age, and then you have a property called age, which is a string that is then converted to an integer optional. If that age is equal to integer age, so then if it's greater than 18, you say welcome to the Army, else print you need to be older. Or if it returns a value that is wrong, like with the E in there, right? Then you say something went wrong. And if you put 17 in there for age, you need to be older. So hopefully that makes a little sense of why you would use the question mark in this value. Could we not even use this question mark here? Just get rid of the string. Well, I guess the reason why to make this a string is so that, again, they're using keyboard input, which has both numbers and letters, right? One way to avoid having this problem would be just to give them optional that they have to put in numbers, right? That's why on a website, right, when you're choosing like zip code, they only give you number options where you can't use that. So you could, another way to avoid this problem would be to, instead of giving the user the option to input with their keyboard, that's why you give them like the date option, where they have to be forced to use specific values that relate to what you're asking them for. If that makes any sense, I don't know. Just like you would on a website, right? I think a lot of the web concepts that we have relate to this as well. Right? Zip codes have to be what? 5 digits, right? 5 numbers? 10 numbers? No, 5 numbers. Sometimes they have the little dash though with a sub zip, I guess. Okay, you ready to move on? Hopefully that made a little bit of sense for you. Did it make sense for you? Somewhat? Okay, I think the more we keep going and trying some of these, the more it will make sense to you, I hope. Okay, let's move on. Go back and update your function to return the age as an integer. If your function always returns a value, make sure your return type accurately reflects this. Call the function and print the return value. Isn't that what we just did? That's what we just did. But we put 20. They put 20 in there. Okay, next one is donuts. Boy, we're hungry too. And bananas and broccoli. Don't you love that? Always food when you're hungry. So let's look at the bottom of this one, okay? Imagine you're creating an app for making purchases. Write a function that will take the name of the items for purchases and will return the cost of that item in the body of the function. Check to see if the item is in stock by accessing it in the dictionary stock. If it is, return the price of the item by accessing it in the dictionary prices. If the item is out of stock, return nil. Call the function and pass the string as it exists. So again, right there they have function prices item string is equal to double. Right? Why is there a double in there?
Because we've got decimals.
Got decimals. That's the first question on the test. Remember, we have a test next week, right? Okay. First question is that. Monday. First question is that. Double has decimals. Question 1. So we'll review. Okay, so let's read the function that they got right there. So it says function price items. Okay, items is basically part of prices, right? And the first item is a string. If the let stock equals stock items, if stock is greater than 0, return price items, else return nil. So let's try it. Function price item make it a string make it a double, make that double optional with the question mark. So if let stock, where's the word stock come from? Well, it's this one right here, stock, is equal to stock, and then item, then if the stock, of course, is greater than 0, it has value, right? Then what? Return prices. And that price isn't the item itself. This is not a dot. Is it greater than? There we go. Else return nil. What did I do wrong? Cannot subscript a value of type string double with an index of type string expression. I mean, it worked up until we got the else in there, right? Right? The first, it actually worked until we put this in there.
We have space.
Where?
It's not space
Let's read it again. Imagine you're creating an app for making purchases. Write a function that will take the name of the item. There we go, chips. Let's just use chips. The name of the item for purchase as a string, and return the double in the body of the function. Check to see if the item is in stock by accessing it in the dictionary stock. By accessing the dictionary stock. If it is, return the price of the item by accessing. Let me see my example on this computer. Oh, you have to give some, you know. It doesn't like item for some reason. Okay, let's see. Let me try print price item donuts. Oh, we need another else in there. That's what the problem is. We need another else in there. Oops, too many brackets. This else will return nil. Now I got too many. That one goes with there. That one goes with there, but still. If let's stock, there's an item. Is it item or items? Item. Still doesn't like this here. Did anybody get it to work? Or you get the same error message I get?
Mine's on the bracket right after that. That one. It says variable binding condition requires initial answer.
So we got prices. We want to compare. So if you have a chip, we want this number, else we want nil. So if we have prices, this item is a string. What if we got rid of the question mark?
There's extra top bracket, the end of the return line.
Which one?
The end of the return line, there's the extra top bracket.
This one?
No, 41. Yes, that's that one. If you get right of that.
Oh. There we go. See, one extra bracket and you go crazy. So we're getting a nil. Why are we getting a nil here instead of a price? Donuts.
D is lowercase.
Donuts is lowercase. What if I put uppercase donuts? Still get a nil. Donuts is greater than 0. Okay, so let's read it again.
Prices. Prices.
What's that?
You should write print prices item, yeah? And then line here. Donuts is 0. Oh,
Prices with a S here.
Oh, sorry.
Prices. Oh, but this is price is what we're looking at. Price here. Mhm.
Donuts is 0.
Donuts.
Yeah, the stock is 0 for donuts.
What if I put a different one in there? What if we put in oh, donuts is here. Oh, donuts is 0. There you go. That's why right there. 0 in the stock. We have no donuts. I have no donut. What if we put in apple? Let's try apple. Apple. Oh, we got 0.5. Why don't we get a here, apple 0.5. So here we go. If the stock item apple is greater than 0, which 6 is greater than 0, then we return the prices, and then the item, which would be this one. So making a comparison. So if let stock equals stock item, so we're comparing this one, is greater than 0. So we have it in stock. I got 6 apples. And how much do they cost? 50 cents. So we get an optional of 0.5 down here. Let's do another one. So we got apple. What else we want? How about chips? We love chips. And I'm getting 2.99. Is that how much chips are? Oh, they are super expensive. The juice is even more. Okay, so let's read it again. So in this function called price, we're taking item and we're making it a string. That string is then going to be a double, which could be the decimal point, right? If the item stock is so it's a variable here, but then they put it into a constant there, equals stock item. Item is a string right there, which is the name donut. And if stock is greater than 0, return the price item. Prices item. Else return nil. So what was it again? Donuts gave us nil, right? Let's try donuts. D-O-N-U-T-S? Donuts? What if I spell it wrong? Oh, that gives me a nil as well. Donuts? And that's a 0, so that gives us a nil as well. What if I change this to a 0.5? What would happen then? Ooh, got an error there. Can't be 0.5. It would have to be what? How about 0.5? There we go. And then I get this. To be 0.5. What do you think? Does it make sense if we read it that way? No.
Because we're saying there's a half a donut in stock.
Half a donut in stock. I guess there could be 2 donuts in stock. How about that? There we go. Still gives us the right number. Anything above 0 is the problem. Once you put a 0 in there, it's going to give you a nil. Okay, you are ready to move on? Let's try page 4. Okay, let's read this one. Suppose you want your fitness tracking app to give users the ability to log food. Once food has been logged, users should be able to go back and see what they ate in a specific meal. Write a function that takes a string parameter where you pass in either breakfast, lunch, or dinner. The function should then return the meal object associated with that meal, or return nil if the user hasn't logged any meal yet. Note that the meal object and a dictionary meals represents the meal log have been created for you below. Call the function once or twice and print the return value. So again, we have something called meals, which has a string of meal. And then we have breakfast meal, which could be bagel, orange juice, or white eggs with a calories of 130. Whoosh. So they make a struct called meal. In that struct, you have a variable called food, which is a string. And then they have a variable called calories, which is a integer. And then they make a variable called meals, which has all your information in there. So we need to write a function that returns meal. Not meals with an S, but meal. This one up here, meal, with a capital M. Notice this one has lowercase, meals. So there's an example there. If we type in, what are we looking for? Function get meal, and then we get the meal, which is a string, and have it return meals with an S, which is this right here, meals. No. I have meals, meal with a optional, then return meal with an S, and then let's get meal. Oops. Yeah, square bracket. Meal, M-E-A-L? Is that meal? Meal. So first making an optional here. Meal? Did I spell it right? Capital M. Whatever this is right here. Okay. So again, if get meal is going to take the value of meal here, meal, and make it a string, and pass it to meal, that's an optional, and then we return the value of meals. So what are we going to print? What part do we print? Print get meal, lunch. So we have lunch. We don't have lunch, do we? I was going to say print get meal lunch. There is no lunch though, right? So it's going to give me a nil. I have nil because there is no lunch here. There's only breakfast, right? So let's try print. We'll just copy this. Oh, and we can put in what? Breakfast. And that'll give us what? Oh, a nil too? Oh, no. I got bagels, orange juice, egg whites, and 530 calories. Whoosh. Okay, let's move on. iOS comes with a few different APIs for persistence or saving data. You'll learn more about persistence in our lesson, but for now, imagine what an app experience would be like if every time you open the app, all of your data was gone. That would be frustrating, right? Write a function that would check to see if your meal log, a dictionary like that in the previous exercise, is saved to a device. If it is, return the meal log. If it isn't, return an empty dictionary of type string any. The code should use in this exercise for retrieving something saved to a device is user default standard dictionary 4-key meal log. This code will return an optional string any if they return a value that is your meal log. If it returns nil, then no meal log has been saved. Call the function and print the return. So they have, again, there on page, they make a function called say get saved log that has nothing in it right now, but then they make it into a string, and what do they say with any? What's the any? Anything in there, right, is empty. This code will return an optional string any if it has a value. If let log user default standard dictionary 4-key meal log return log, else return nothing. I guess a colon. I don't know, let's try it. So again, we write another function, get saved log, and that is a string, and anything that's been saved, I guess. And then make that function with something called an if statement, if let log equal to and user default standard dictionary, user defaults standard dictionary for key meal log return log, else whoops, return nothing, or I guess I have too many. Value type user defaults has no memory dictionary. I spelled it wrong. There's no S in dictionary, is there? There we go. And then this one is this way. Okay, so what do we get? Too many of these. So in this case, we're getting the dictionary here. So let's print get saved log and so I'm getting this because it hasn't been meal log. What are we getting? Meal log. Okay, let's read it again. iOS comes with a few different APIs for persistence or saving data. You'll learn more about persistence in another lesson, but for now, imagine what an app experience would be like if every time you open the app, all your data was gone. That would be frustrating, right? Write a function that would check to see if your meal log, a dictionary like that in the previous exercise, is saved to the device. If it is, return the meal log. If it isn't, return the empty dictionary, which of course is that's this right here. The colon. The code should use in this exercise for retrieving something saved to the device is user default standard dictionary for key meal log. This code will return an optional string any. If it returns a value that is your meal log, if it returns nil, then no meal log has been saved. Call the function and print value. Print save get saved log. Again, we get this. Do you think that's right? I don't have a log, do I? I don't think we've saved anything, so that's why. And I think it's just an example of why you would use the any. Okay, let's move on next page. We'll do one more exercise. I'm going to have to go deal with some phone calls. Okay, this one is, I'm on page 5 here. Create a computer struct with two properties, RAM and year manufactured, where both parameters are type integer. Create a failable initializer that will only create an instance of computer if RAM is greater than 0. If the year manufacturer is greater than 1970, then less than, so we have to do a comparison, right? Is it greater than 1970 and less than 2017? So you're gonna have to do an if statement. So let's think about it. Let's make a struct. S-T-R-U-C-T, struct, that is a computer. Oh, and if you want to go to the Computer History Museum, I'm going on Thursday at 12:30. Have you ever been there? If you haven't been there, you should come. Field trip, just show up at the door around 12:30, 12:45. We usually start the tour. If you've never been to Computer History Museum, Thursday, March 15th, 12:30. And tour's about an hour and a half. Depends on if you read or you just walk through. Just pointing it out, I saw the word computer here and I said, oh. Okay. So if you haven't been there, come on Thursday. So let's make a variable. We're doing RAM and what else? We're doing year manufactured. So we got RAM, and that's an integer. And then we have a variable, and that is year manufactured. Manufactured, fact, F-A-C, factory, U-R-E-D, manufactured. And that is also an integer. Is it capital M in manufactured? Yes. Okay, struct. What did I spell struct wrong with a capital S? There we go. So we make a struct structure that is a computer. We have a variable called RAM. That's an integer, and a variable called year manufactured, which is an integer. So now we need to make the parameters. So we struct with two properties, RAM and where both parameters are integer. Create a failable so this is going to be a way of testing RAM and year. So this is where you use the INIT with a question mark. So we got RAM, which is an integer, and that has and as well as we have year manufactured, which is an integer. If RAM is greater than 0 and year manufactured is between 1970 and 2017, then self RAM equals RAM, else self year manufactured, else return nil. So let's try it. We're going to do an if statement. If RAM and we're comparing is greater than 0, right? Greater than 0. And with the two and signs, and the year manufactured is greater than 1970, and the year manufactured, manufactured is capital M. Capital M, manufactured is less than 2017, then what do we want to do? Well, we want to find out, put the RAM inside RAM. So the word self, RAM, is equal to RAM. And then we got to put another else. This is where we got to call nil. Return nil. What did I do wrong? Failable initializer. Initializer requires a body. Oh, afterwards. Yeah. Yeah. Where do I need curly braces? Here? There we go. And where's the closing one? This one goes with this one. This one goes with this one. This one goes with this one. This one goes with that one. This one goes with that one. This one goes with that one. This one goes with this one. This one needs to go. There we go. That looks better. No?
The same line. Said that year manufactured equal year manufactured.
Oh, you're missing manufactured. There we go. Self. Oops. Self. Year manufactured equals to year manufactured.
Should we close braces?
Need this one back. Okay. Whoosh. Okay, so again, let's just read failable initializers. Okay, so these are failable. Create a computer struct with two properties, RAM and year manufacturer, where both parameters are a type of integer. Create a failable initializer that will only create an instance of computer if RAM is greater than 0. So this is saying only work if RAM is greater than 0. And so RAM and year manufacturer won't work unless there. So let's try it. So down there at the bottom there. Create 2 instances of computer using the failable initializer. One instance should use values that will have a value within the optional and syntax to unwrap each of the computer objects and print the RAM and year manufacturer if the optional contains a value. So we make one called failing computer equals computer RAM 0. And so, of course, this is going to give us a nil. And then the second one says let succeeding computer equal RAM computer. So let's try. Let's see. So we got let failing computer computer equal to computer with a capital C, which is this right here. Equal computer, and of course, let's see, we have RAM for our computer, and we make that 0. And then we have year manufactured, and we make that 1960. And of course, it's going to give us a nil because RAM is equal to 0. What if we put 1 in there? Still gives us a nil because it's less than 1970, right? What if we put 1980 in here? I get a computer. Okay, so this consonant here is not really a failing computer, it's a good computer. Good computer. Now, good computer makes a good computer. Again, 0. It's going to give me nil here because this one, it doesn't pass the test, right? But this one does. But if we put 2 in there, it passes the test, I get a computer. If this is 1960 though, 1968, will it pass? I'll get a nil. So again, this option, or what they're trying to tell you here, is this a failable initializer. So we're making something, in this case we're making a computer if it has RAM and it's not too old. What do you think of that one? Okay, hopefully you want to do the last one together? Okay, we'll do one more. Last one, page 6. I didn't print it all the way, so we're going to have to make up the bottom. Let's read. These exercises reinforce Swift's concept in the context of fitness tracking app. Have you ever accidentally tapped a button in an app? It's fairly common. In your fitness tracking app, you decided that if a user accidentally taps a button to start a workout and then ends the workout within 10 seconds, you simply don't want to create a log that workout. Otherwise, a user would have to go and delete the workout from the log. Create a workout struct that has properties start time and end time of the type double. Yes. Dates are difficult to work with, so you'll be using doubles to represent the number of seconds, since midnight would represent 28,000 seconds, which is exactly 8 hours. So the start time is 8 a.m. Write a failable initializer that takes parameters for your start and end times and checks to see if they are fewer than 10 seconds apart. If they are, your initializer should fail. Otherwise, they should set the property accordingly. So again, this is just to not save something that you accidentally tapped. And we all done that before, right? Tap something and you didn't want to do it. Okay, so let's write it as struct workout. And we got a variable, which is start time. Is it capital S? No, lowercase. Start time. And let's make that a double. And we have a variable end time. That is also a double. And then just like in the last lesson, the failable initializer is the int with a question mark. INIT with a question mark. And so we're using this to test. So what are we testing? Well, we're testing start time, and then we're testing, which is a double, and then we're doing start time and end time, which is also a double. And what are we testing? Well, we're testing to see if the end time and start time are less than 10 seconds, return nothing. Else, we're going to put some value in start time and put some value in end time. So we're going to do what? We want an if statement. If end time and, well, not and, but they got a dash there. Start time. Start is less than 10, I guess, seconds. 10. Then do what? We want to return nothing. Nil. Else, what do we want? Oh, we want to put some value in there. We want to put a value in for start time, self, start time, equals start time. And then another self, end time equals end time. Self, end time equals end time. So we got some value. Okay, I'm two expressions. I got wrong bracket here, don't I? This one needs to be this one. There we go. How's that look? Better? So this one goes with that one. This one goes with that one. This one goes with that one. And we have an extra one here. There we go. And after else, expect after else. What did I do wrong there? Oh, you need another bracket there. Okay. Okay, so we have a struct. Let's read it again. The struct is called workout. It has two variables, one that says start time and end time. And we're testing to see, and this is our fail-safe, a failable initializer, right? So we don't want this to take place. We don't want to store any start time and end time if they started with less than 10 seconds. Does that make sense? Okay. So let's do some code down here to put some data into it.
I think we need one close bracket.
Thank you. That fixed it. Thank you. Okay, let's look down below here. We got let fake workout equal workout start time 5,000 end time. That's 50,000 end time. So what are they saying about the timing? Is that it starts at 12 o'clock and it's in seconds? Let's read it again. Dates are difficult to work with, so you'll be using doubles to represent the number of seconds since midnight. 28,800 would represent 28,800 seconds, which is exactly 8 hours, so the start time is 8 a.m., right? A failable initializer that takes parameters for your start and end times and then checks to see if they are fewer than 10 seconds apart If they are, your initializer should fail. Otherwise, they should be set the properties accordingly. Again, we're going to put the time and start time and end. So let's make a constant that is a fake workout. Fake work out. Oh, I have a lowercase o there. Out. And then of course our struct is called work out. Work out. And what do we need to initialize it to? Oh, we got to put some start time in there. So let's say start time. Here, let's just click here. Start time and end time. So what would be less than 10 seconds? What do they have in there? 50,000? Like that. And then what's end time? They have 50,002. That? Yeah. So this would fail then, right? I get a nil right here, right? But if this is more than 10 seconds, so that would be 50,000. Let's make it 4 like that. What would I get then? I get a workout. Right? So this is less, if the timing between these two, this is not going to happen. If the timing is correct, this is going to happen. What do you think?
I have a question. You shouldn't return anything in the else class.
Which one?
In the function, in the yes here. In
Which?
the else class, we should return anything or nothing.
Well, it's not putting any value in here because they don't have a start time and end. Well, they do have a start time and end time, but they're within the parameters. I mean, we could, print, right? But you don't have to print a value. All it's trying to say is that are you going to save the workout, right? That's all it's saying. You don't really need to know what these values are. If it falls within, if this initializer falls within the parameters, then hey, you can save this workout or do workout. What do you think?
The parameter is okay. We should return the value of the time of workout, for example, and time.
Yeah, well, we can, like it is there on line 35, you could print workout start time, print workout end time, right? I just didn't go through that. I figured.
About that line, right? In its question mark, it means we should have a written value all the time or no?
Which one?
About the initializer, that
Here, this one?
yeah, it means we should have return value all the time.
Yeah, that's why the nil is there.
Yeah.
So,
It's just return nil, nothing.
yeah, if it's less than 10 seconds. See, that's where the 002 will return nil. Right? It's less than 10 seconds there. And if it's more than 10 seconds, it'll store some values in there, whatever the values are. So hopefully this helped you figure out what the initializer are. I know it's a lot of work, but I'll try and continue to do the lab with you so that we can all learn together. Okay?